Everyone, welcome to AI Bots. This is my very first video on this channel, and today I will be covering the attention mechanism. Attention mechanism, which is the core principle behind working of the large language models. So, large language models, if I explain you in a very layman terms, basically it is the AI based models which are able to understand and generate human language, right? And we all have been encountering such models in the recent times. These, uh, for example, to name a few, like ChatGPT, which has been has created a lot of buzz, and we all have been using in our daily lives, whether it's ChatGPT or whether it's Claude 3, whether it's Llama 2, whether it's Gemini, to name a few, or even the recent one, Sora, which is a text to video based model, right? Some of these are open source, which are listed in Hugging Face. There are multiple such models, multiple open source models which are listed on Hugging Face. And if I explain you, give a brief about Hugging Face, so basically it is a marketplace for all such open source model, right? And closed models like Claude 3, ChatGPT, all these are uh, closed models which you can access via API. Now, if you would have asked this question 3 years back, if these models work so well, then the answer could have been very different. This is because the previous architectures have had certain issues, whether it was related to scalability, whether it was related to short term memory, or whether it was related to training complexity, right? Then what made these models work so well? This particular architecture, transformer architecture, has led to address all such issues. When I say how was this introduced, then let's go back in 2017 when this paper, Attention is All You Need, was published by Ashish Soswani and his fellow colleagues at Google Brain. It was a major breakthrough in the world of large language models because it introduced a transformer architecture that led to address all such major issues that the previous architectures had. But what goes inside? What exactly does this paper talk about? Let's go one level deeper. Now, if I relate it to a brain, relate to our daily lives, when you read a book, our brain intuitively gives attention to certain words, certain phrases. It is able to understand what exactly the phrase, the whole passage says. What's the entire book is all about. We are able to understand the entire book, right? So our brain very intuitively emphasizes, focuses on certain words, certain phrases, certain passages, right? And with that, it is able to understand the entire content of the book, right? Similarly, in the large language model, the attention mechanism enables the model to understand the whole context. Let's take one example to understand it. I'm going to market to buy apple and orange. I'm going to market to buy latest version of apple. Now, while we know which apple we are talking about in the first and second sentence, the first sentence could be a fruit, and the second sentence is potentially a let's say any apple product, right? So, with the help of attention mechanism, it actually connects each word to word connection in relation to their meaning, in relation to their parts of speech. It selectively prioritizes certain words, or would say the most relevant parts of the entire input data. So for example, in the first sentence it will focus on orange, so that it is able to understand, okay, this particular apple could be related to a fruit. Similarly, in the second sentence, when it focuses on version or latest, and with that it is able to understand, okay, what potentially this apple could mean, right? And this is what the attention mechanism enables the model to help understand, to make it understand what exactly this whole sentence is all about, right? Now if I explain how does it how it is empowered to do such, do such calculations. So I will explain you with a very physical world example. Let's take a college phase example. Imagine starting imagine starting a new phase in the college, and we have a batch of 6 students, right? Now each student has their own characteristics, their own aspirations, own goals, right? If I would want to, you know characterize these students in the, let's say, uh, in the format of 7 dimensions or 7 parameters. So I would like to represent, let me take a pen so that I will just draw out these two additional uh, parameters as well. Let me take a one music and one dance. Now, on these 7 parameters, every student will have, different set of interest correspondingly, right? So someone will have aspiration for MBA, someone will have aspiration for MS, someone will have knack for drinks, or someone would be very much interested to travel or music or dance eventually, right? So if I want to visualize, sorry, I have a bad cold, so yeah. So if I want to visualize it, then matrix could be one of a very good approach to map it, right? So can we say that this is a matrix of 6 rows and 7 columns? That is 6 cross 7 matrix. Let's name it as Q matrix, right? All right. Now, once the college kicks off, everybody gets chance to interact with each other, right? And based on the interests match, based on their characteristics match, someone will form very close bonds. Someone will have like formal interaction, or someone still have no or least interaction, right? So if I want to, let's say, if I want to visually see it, then can we say that, let's can we say that this such kind of representation can help us visualize these interactions? So all these individuals are listed in the rows and even in the columns, and every individual has certain scores corresponding to each individual uh, cell, right? You can see that this is a matrix of 6 cross 6, right? Now, if I want to understand what exactly is the mathematics behind it, so basically it's a dot product between matrix Q, that was the previous matrix where every individual was represented uh, corresponding to their characteristics, 6 cross 7, and dot product between its Q matrix and its corresponding transpose. So if I recall what exactly is the transpose, basically it is the matrix where the rows and columns gets interchanged, right? So this dot product will give me a matrix of 6 cross 6. So if you remember what we have studied during our earlier classes, during our school times, uh, a dot product between A cross B and B cross C will give us a result matrix of A cross C. And this is exactly what has happened here, right? Let's zoom out one of such case. Let's zoom out Monica's case where she has, when she has come with her individual characteristics, and now she has interacted with every individual. So how does this look like? Let's zoom out the same table, but just for one use case. So she has had certain characteristics. She was a MBA aspirant. She had a knack for trek, and for rest of the characteristics she was like, okay, I mean, not so much interested, right? Then when she got chance to interact with everyone, all the scores have been calculated. So basically each score you are seeing, these are actually the interaction, the product between all the characteristics of this individual. I mean, of course, I'm ignoring for now. Now, let's take Phoebe as an example. So basically 0.16 is the value that have that has been found after the that has been found uh, after the interaction has been calculated between Monica all characteristics and Phoebe characteristics, and so on, right? And based on that, because Chandler also has similar characteristics like Monica, and even Joey also had similar characteristics, interest as of Monica, that's why their scores are maximum. So if I recall their their individual characteristics, so you will see Chandler also had knack for MBA, and Joey had knack for Trek, right? And that's why their scores have, were maximum. I hope you are able to follow me to throughout. Now, so after these interactions, their original characteristics will get changed or revised, right? So the initial matrix, which was Q, now can we say that it after the interaction, every score would now be revised, every score would be basically updated, right? And can we conclude that these revised scores not only just represent the individual characteristics of that person, but also contains the between interaction score with her with her co-colleagues or whatever co-students, right? So it also captured the essence of the interactions, right? Let's name it with the matrix of T, right? So to summarize so far what we have done, we have seen a Q matrix, which was 6 cross 7, where there were six individuals and they had certain individual parameters, individual characteristics, which was a raw, we can say a raw matrix, right? Now we have calculated the interaction score, where each individual gets chance to interact with one another, and we have got a new matrix which is called the interaction matrix or attention matrix, whatever you call it. This is 6 cross 6. Mathematically, the this we have got by calculating a dot product between this matrix and its transpose. Now, once we have received this attention matrix, we saw how after the interaction matrix, the initial matrix will be transformed into a revised values, which we have seen how it is 6 cross 7. Mathematically, if you ask me, how we have got transform matrix, so basically once we have the interaction matrix ready, then we calculate a dot product between this one and the Q matrix. And yeah, exactly, this is the approach for getting the transform matrix, right? Okay, now let's try to connect it to the attention mechanism, right? What exactly happens when you feed a model with an input of certain words, uh, each word having different set of characteristics, different set of individuality. So let's say how does this how we can relate it, how we can connect it to the attention mechanism in the large language model. So I have taken these two statements. Let me take a marker here. I have taken these two similar statements where I have, tweaked a little bit, replacing he with it in the second sentence, right? Now, while our brain intuitively finds out who he is being referred to and who it is being referred to, the model will perform the self attention mechanism to relate all input words with each other. So just like how we have seen previously in the previous example, how each student having their own different set of characteristics, how their different values were mapped corresponding to those characteristics. Similarly, each of the words in the input sentence will have certain values mapped to them, mapped for different parameters, right? And these parameters, just like in the student example there were 7 parameters, here could be 100 parameters, or even, sorry, 100 parameters, or even 500 parameters, or even 2000 parameters, right? Depending upon what we define in the model, right? So this, how each word is mapped to these 100 parameters, how their values are mapped to those 100 parameters, or whatever 500 parameters, whatever we define. This concept is called embedding. And this is also one of the very important concept, and I will try to cover it in my upcoming videos. But for now, just try to relate it with the example that we have gone through, where each student had their own different parameters mapped, and once they interacted with each other, so all these parameters, all those values got chance to interact with other students values, right? So this is what happens exactly in the model, where each word gets chance to interact with each other. So basically their characteristics are uh, characteristics are interacting with other words characteristics, right? And based on that, it is able to generate how which words have the maximum bond, and which words had the minimal bond, and we can ignore such words, right? For example, it will be able to understand he relates to beer maximum, and in the second sentence it is related to honey, it forms a closer bonds with honey related to others, right? So, and based on that interaction, it is able to understand the entire context of the sentence, which helps it to calculates the which helps it to output the next token in both the sentence. And to predict the next token, it actually calculates the probability score for for its potential of words in its vocabulary, right? And based on the highest probability score, it generates the output, right? So it generates, here could be the tasty, and even in the second time in one shot it can generate the sweet as well, right? And that's why, in whenever you put an input sentence in a large language model, you get different words, not exactly the same words, not exactly the same line of words, right? That is the reason. I hope you were able to follow me throughout this journey. And if you have any questions, if you have any feedback, feel free to put this over in the comments, and I will try to work upon that. And even I will, for your questions, I will try to answer it as much as possible. So thank you for listening this, and I hope you have enjoyed this video. So stay tuned to AI Pods, and feel free to subscribe and like this video. Thank you.